Hello everyone, welcome back to my online class with Miss Maybe.
Okay, today our topic is about logic gates and circuits. Logic gates. Logic gates are electronic circuits that operate on one or more input signal to produce standard output signal. Are the building blocks of all the circuits in the computer. Some of the basic and useful logic gates are AND, OR, NOT, NAND, and NOR gate. Let's see more example about AND gate. AND gate is a logical multiplications operations. So, example here, if the input A 0 and then B 0, this means that 0 times 0 equals 0. 0 times 1 equals 0. 1 times 0 equals 0. 1 times 1 equals 1. Okay, so it means that generates an output signal of 1 only if all input signals are also 1. This is the symbol. For the expression, algebra expression, we can write C. Example, the output is C equal A dot B. Next, OR gate. OR gate like this, as you can see, this is the symbol. The first one, the input is A. The second input is B. The output, let's say, is C. So, C equal A plus B. This means that OR gate is a logical addition operation. Now, let's see the truth table. Example, input A is 0, input B 0. This means 0 plus 0, 0. Input A 0, input B 1, so the output will be 1. 1 plus 0, 1. 1 plus 1, 1. It means that based on this truth table, it means that generates an output signal of 1 if at least one of the input signals is also 1. Next, NOT gate. NOT gate, as you can see, is like small triangles with a small bubble. NOT, so it means the opposite. A, the output, this symbol, not A. So, if the input 0, so the output will be 1. Input 1, the output 0. So it means it will reserve of the input signal. Next, NAND gate. Okay, NAND gate, this is the symbol combined with NOT and AND. So the symbol like this, and then as you can see in front is the put the bubble here. So 0 times 0 equal 0, but as you can see is not. Let me write here 0 times 0, 0, but it's not, so 1. 0 times 1, 0. Not A, 1. Same like this, not A, 1. 1 times 1, 1, but not A is become 0. So it means that 1 if any one of the inputs is a 0. The output 0 when all the inputs are 1. Okay, as you can see, this is the expression algebra like this. Okay, NOR gate combined with NOT plus OR. Before NOT plus AND. Now, you can see the output here is opposite from OR gate. So, whatever the result in the OR gate, so the opposite. Example, 0 plus 0, 0. But because not or NOR gate, not OR, so it's opposite. Or 0 plus 1 equal 1. The opposite, 0. The expressions, as you can see, B equal A plus B with the line on the top, or equal A not A dot not B. Okay, let's see about logic circuits. When logic gates are interconnected to form a gating or a logic network, it is known as a combinational logic circuit. The Boolean algebra expression for a given logic circuit can be derived by systematically progressing from input to output on the gates. Now, the three logic gates AND, OR, and NOT are logically complete because any Boolean expression can be realized as a logic circuit using only these three gates. Example this. Now, example, there are three inputs. So, if this symbol, the small triangles with the bubble in the front, is mean that not A. This symbol identify OR. So we can see B plus C. And then connected with the AND symbol. So D equal not A dot open bracket B plus C. A is this, B is this. This one, B plus C from this. Okay? Now, let's see another example. Okay, this symbol is OR. That's why A plus B. And this symbol, as you can see, is connected from A and B. So, A dot B. Or we can say A times B. Then, This symbol is not. So A times B with the line on the top, not A times B. And then you connect it together with this symbol N. So in the end, the result will be C equal the first one, A plus B. Then the second one, A times B, not A times B, and use dot symbol.